In this lesson, we shall focus on conic sections, math 141, and we shall be looking at the calculus component of mathematics. Right, sketch the ellipse, identify the foci, the vertices, and ends of the minor axis. This was given as a home activity in our previous gathering. And obviously, when I gave this one here, you actually obviously went to try this, and I'm sure that you possibly enjoy it. We have a perfect opportunity to take a look at this and make sure we reason this carefully. Right, so we have x squared out of 4 plus y plus 2 squared. You divide by 9, and the result is 1. Right, now, we remember last time. Therefore, we choose the biggest one. The biggest one is always called a. So the biggest one is a squared, is called 9. The smallest one is b, which is called 4, because it's smaller than the 9. Right, and we take the square roots, and we have the square root of a squared, and we have plus or minus the square root of 9. Getting a equals plus or minus 3. Right, we have b squared is plus or minus the square root of 4. And obviously at this point, in principle, we just take the a to be a 3. But obviously you can get a plus or minus here, and you continue with getting a plus or minus 3. That is fine, you can take that. And then the b would be plus or minus 2 there. Right, so this would therefore mean, that your a is 3 and b is 2. Okay. At this point, we analyze this with much care. And we look at the next question we shall discuss. All right, so if this is the a and this is the b, and indeed 3 is bigger than 2, so that we always say b is smaller than a. So the biggest one is always a and bigger than b. Okay. So we want to determine the foci. So we find the center first. Right, we find the center. The center will be 0 minus 2. Right, and then now when we do this, we always do this one, which is a squared minus b squared, which means that you're going to have the a squared. The a squared is already 9. The b squared is 4, giving us the square root of 5. Okay. As a consequence, what we're able to achieve here become the following. So now, because of the a equals 3, and 3 means that the measure axis is parallel to the y-axis. Right, since a equals 3, this implies that the measure axis is parallel. It's parallel to the y-axis.
Sorry.
Yes, please.
Hello.
Yes, please.
So won't or is it not compulsory rather? Won't 4 be A and then 9 be B? Or it doesn't matter?
Yeah, okay, that's a good question. It matters. Right, it matters. How? Because according to their formulas, so their formulas in the textbook, although in general somebody can think it doesn't matter, but in the textbook, we actually have the following formulas. We always say there is x minus h, you square it, and then there is y minus k, we square it, we divide. So now, and this is always equal to 1. There's a time when you put the a here and you put the b there. And then there's also x minus h, and we put the b there, right? So it does matter where we put the b and where we put the a. So, right, because the b can be in any of the places, but doesn't mean we just put it anywhere, right? And then we also have y minus k squared divided by a squared, so that you have a squared, and the result is what? The result is 1. Now, we actually put the a here under the x, and we put the a sometimes below the b. Right, so we continue. Right, so we continue. Right, we continue. We continue. Okay, I want to discuss these particular formulas because they are very, very important. So we put the a here, and when the minute we put the a here, it means that a is the biggest one. So the minute we put the a here, it would mean that b is less than a. It means that the a is the biggest one. So the a always remains the biggest one. So if the biggest one is under x, if the 9 were below x squared, like x squared over 9, then the 9 would have been a still. Okay, it is a choice that has been made to just make sure that whenever we speak about a, we speak about the dominant one, the biggest one. Why? Because it is able to tell us the measure axis and where the measure axis is going to be. Because now when we get a equals 3 here, a equals 3, we know that the biggest one between 3 and 2, b, the most smallest one is b, and the biggest one is a. Then since a equals 3, which is the biggest one, this implies that the measure axis is parallel to what? It's parallel to the y-axis. Why? Well, parallel to the y-axis because this would mean, because a is bigger, and this would mean that the measure axis is parallel to the x-axis. So parallel to the x-axis. Then you already know. Here, this one, because if the biggest one, a, is under this means that the measure axis is parallel to the y-axis. Parallel to the y-axis. So those are the kinds of things that remain very important. Okay. Now, what then? Yes, please.
So basically, wherever we see the biggest denominator, that's the a.
Yes, always. So the a can be below the x term, it can be below the y term, but the biggest one is a, irrespective of its position. Because you see, there is a squared below x, but the a squared is also below y. But this a tells us the measure axis. So here it means the measure axis is on the y, it's parallel to the y-axis. Here it means that the measure axis for this particular ellipse, the measure axis is parallel to the x-axis. So by looking at this equation, we're able to tell that wherever the a is, the measure axis is going to be. And for instance, if this one, the a squared is below the x, it means that the measure axis is parallel to the x-axis. And therefore, it means that this kind of an ellipse is going to be lying down. Then we already know. This one, because the measure axis is parallel to the y-axis, then we know very well that it's going to be like this already, without numbers or anything like that. So that is the reason. But it is always the case, and obviously it's not a question of reinventing the wheel, but it is actually by dint of, right, it is by virtue of the textbook's approach to this, and we are following the textbook, right? And obviously, you see, different books can have their own interpretation for this, but for the sake of our current book, right, so we obviously stick to these notations, and we maintain these. But also, this will be the same in your tests. I'm sure because the lecturers use the same book. Right. So since the lecturers use the same book, they will expect you guys to do things in the same way. So they cannot expect, if a student is going to say A squared is 4 and B squared is 9, they might mark you wrong. They might mark you wrong because they will just say no, because the textbook is saying the biggest one is A. So why are you saying B is the or B is the biggest one?
Sorry,
Yes, please.
because I thought we had to go according to the standard
Formula.
equation of an ellipse used.
Yes, the standard equation of an ellipse. I agree with you. So there are two standard equations of the ellipse that we studied. Okay, so in particular, so I'm gonna state the standard equations of the ellipse that we studied, because it is very important that we have, because you see, it is either we study a parabola or an ellipse. But now we must also study a hyperbola, because it's there in the textbook, but the TAT does not include that. Maybe there's TAT 11. Okay, TAT 11 is the one maybe that is going to have the rectangular hyperbola. Right, so, but I want to give a summary of the kinds of things you're expected to learn and the things you're expected to know. Right, so now I want us to speak about the two equations of the ellipse. Right, the two equations of the ellipse in general. Okay. So we speak about the ellipse. This is just some theory for all the problems in the textbook and the TATs. Right, there is what we call the ellipse with center. Okay, this one is from the textbook. Right, and this one is from the textbook. It is from page 740. Okay, so I'm taking it verbatim as it is. Right, so now the ellipse with center, right, with center H and K and merger axis. Right, and merger axis parallel to x-axis. This is how we introduce one of the equations. And then we then say x minus h squared, we divide by a squared. Then we do y minus k, and k always goes with y, and h always goes with x. Okay, this is the textbook. And then this is equal to 1 always, but we put in brackets, in square brackets, and we say b is strictly smaller than a. Okay, that becomes one of the equations of the ellipse. But there is another ellipse. Right, now, this other ellipse is very similar. There is an ellipse with center. With center HK and merger axis. Right, the center is always H and K, but now the merger axis, we always speak about the merger axis. Right, the merger axis that is parallel to the, or parallel to y-axis. So now, if the merger axis is parallel to the y-axis, then what is the equation? Then we use this formula. So there are two kinds of equations we use. Right, so now it's going to be this one over b squared. Okay, in the whole textbook, we use these two equations for the ellipse. And then we have y minus k over a squared is equal to 1. B is less than a. Okay, the ellipse with center h and k and merger axis parallel to the y-axis. The merger axis parallel, so b is always smaller than a, always. So, but if the merger axis is parallel to the y-axis, then the a squared is below the y term. But if the merger axis is parallel to the x-axis, then it means that the a squared is below x. Measure x is parallel to the x-axis, below x, the a squared. So the a squared is always, so it's not one equation we study. The question is, what is the equation for the ellipse? We can't say is the top one only that always a is below x. No, a can be below y. But how do we know? A is the biggest one because A is bigger than A. A is bigger than B. So my point is, we study this, but for the parabola, we study 4 equations. But for the ellipse, we study 2 equations. But for the hyperbola, we also study 2 more equations. Right, so this becomes extremely important. Okay, now let us solve this problem. We've already seen that here we have x squared divided by 4. Y plus 2 squared divided by 9. The question is, what formula are we going to use for this one? Which one? What is the general formula? Perhaps that is the question. What is the general formula that we need to use to solve this problem? But we use the general formula that is in the textbook. All right. So so now we just look at where the biggest one is. The biggest one is below y, so we shall use. So every time there's x minus h, so the h goes with x minus h squared. So you always write this first. Y minus k squared equals 1. And then below the y, you always put, because we have the biggest one, so you're going to put a squared. And then below the x is smaller, then you're going to put b squared. So this is the formula that you're going to use. But this formula in the textbook is always b smaller than a, or a smaller than b. With this one, we are able to see some things. And once again, it means that when we look at this question, we are able to see some things here. So which means that we can say b squared is 4. It's sort of the smallest of the 2. A squared is 9. This you can just say a is 3. Normally would require positive values of a and b according to the textbook. Okay, everything we are following the textbook. To say we solve the charts, but we don't just solve the charts using our own notations and things. We follow the textbook. But for us to find the foci, we need to know the center. But for us to find the foci also, we must know the formula. C is equal to what? A squared minus b squared. What is the a? You can start. A squared is 9. And the b squared is a 4. Giving us square root of 5. But for us to find the foci, we must also know the center of the ellipse. What is the center? The center of the ellipse is going to be, this one is going to have x goes with 0. And then y goes with -2. Okay, this becomes the what? This becomes the center. But now, is this enough? No, this is not enough. Where is the major axis here? Where is the major axis? Because we must know where the major axis is for us to be able to find the foci. We can't just find the foci if we don't know where the major axis is. How do we know where the major axis is? We say since. We look at the A, the biggest one. So now we look at the fact that since A is 3, this implies that the biggest axis, we call the major axis, is parallel to the what? It's parallel to the, because it's below y, then it's parallel to the y-axis. 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 Okay. Now let's continue with our analysis of this. Now, why is this major axis so important? Well, because now we must know because the foci is from the center. Because now, when you draw this graph, you'd have to position the center. When you position the center, let us have a rough sketch of what is happening here, because we need to sketch this. So the major axis is parallel to the y-axis. So it's going to be vertical, sort of. And the center is at a point where x is 0 and y is -2. So that is the center. Right, x is 0 and y is -2, like here. That is the center. You can write 0 and -2. So this one is the what? This one is the center. Right, let us analyze even further. So now, if this is the case, we continue with our analysis and we then say, the major axis, therefore, must be parallel to the y-axis. But because the center, the major axis, passes through the center, or the center is on the major axis. So in this case, the major axis is not just parallel to the y-axis, but is on the y-axis. In particular, the major axis in this case is the y-axis. The y-axis is our major axis because the center is on the y-axis. Okay, right. Next. So now we have the C, which is the square root of 5. But for the foci, we remember the definition of the foci. Right. The foci is always what? Is always a certain distance away from the vertex. Right. So in this case, obviously you need to think about this. The question then becomes, so now these the foci will therefore lie the square root of 5 units above and below the center. So the center is this, and then you just above and below. So above, you measure this distance. Above, you go above. And then how do you go above this? To go above this, it means that you take this center, and then you add this, then you go up. Right, so when you go up, then this, it's going to become the foci. So it's going to become -2 plus the square root of 5. Okay, then now you go down. -2 minus the square root of 5. Okay, you go down now from the center. The center is -2 there, so you just go down by that distance. And therefore, this one is going to give us the focus. And the other one also is going to give us the focus. So this is our focus. And this is also our focus. From the center. Now, we actually then reason even further. Right. What more do we need here? Right. What more do we need here? We also need to determine the... Okay, this is the measure axis, but now if we have the measure axis, this measure axis must also be essentially be determined. We must determine the vertices, and these vertices themselves would be what? Right, so the vertices themselves must lie on these, measure axis. The vertices must lie on the measure axis, and then the minor axis will contain also its own endpoints. Right, so now I want us to talk about this. Right. Now, since I want to write here, since A equals 3, this implies that the measure axis extends 4 units above, 4 units above, in particular, extends 3 units because A is 3. So the measure axis is going to extend 3 units above and 3 units below the center. So now you take this one. It is at this point, because A is equal to 3, then it means that you're going to go up 3 units. Right. So if you go up 3 units, what are you going to get to at this point? You're going to get to this point. So it means, therefore, you add 3 to minus 2, then you get a 1. But now you also go 3 units down. So it's going to be minus 5. Because minus 2 minus 3 is minus 5. Right, and therefore the ellipse is going to be like this. This is the shape. Because now it's just going to... It's going to be through the... It's going to be through the vertices. So which means that here we would have the vertices. It's going to be through the vertices. What are the vertices? The vertices would be, as indicated at this point, would be this one. So this one is going to go up, but it's 0, 1. And the another one is going to go down. X is 0 and Y is minus 5. So X is 0 and Y is minus 5 is one of the vertices. And how do you get the vertices? The vertices, you use A, the biggest one, to get the vertices. Always use A. Just add and subtract from the center. That's all. Okay. Right. And now we continue as follows. Right. We continue as follows. Right. We continue as follows. Okay. So the vertices are 2 of them. 0, 1. Okay, they are 0, 1 and also what? And 0, minus 5. We've got the vertices and they're there. 0, 1, 0, minus 5. Then the foci. How do you get the foci? You take the center. What is the center? 0, minus 2. We got it from here. 0 and the y is negative, negative 2. So the center, you can just read it off from there. But there's a transformation that we do from the center to get the focus. We perform a translation. What translation do we perform? We use the C to add and subtract. So in other words, you'd have this, you will move along the axis of that is parallel to the major axis. So it's vertical, the major axis is parallel to the y-axis, so it's gonna affect the y coordinate. We leave the first coordinate, so we affect 2, but we're gonna add, subtract the square root of 5. Add, subtract the square root of 5. Add, subtract the square root of 5. Add, subtract. Yeah, so this one becomes the what? This becomes the foci because there are 2 of them. There's one with the plus that goes up like this, and there's another one with the minus there. Okay, that goes down. And then now what about the ends of the minor axis? How do we get the ends of the minor axis? The minor axis has to do with the B. So we take the B, we add and subtract for the minor axis. The major axis we use A, and then the minor axis we use B because B is the smallest one. Okay, let us reason this. So, which then means you'd have the following. So you're going to have the center 0, minus 2. And then you add B. Okay, let us deal with this. But because it affects, it is this minor axis is parallel to the x-axis. So it's going to affect the what? It's going to affect the x component. Okay, it's going to affect the x component. So now we're gonna have that one. But remember that it's gonna pass through the center. This minor axis is gonna pass through the center. Right. So that is why then, if it passes through the center, there's 0 minus 2. Right. Right. We continue. Right. Okay, now let us deal with 0 minus 2. And then now you just add the b. Like if you want to go to the right, you add the b, but you add to the x component. So that is why then it's gonna be this one. It's gonna be you add to the, so it's gonna be 2 minus 2. And then here you subtract from the component. Minus 2 minus 2. So in other words, that is why then when you want to get the minor axis, what you call the ends of minor axis. The ends of minor axis. How do you find the ends of minor axis? Right, to find the ends of minor axis, you take the center, you add and subtract to 0, the x component. So because it's 0 plus or minus 2, because the b is 2. And then now you're just going to get the plus or minus 2, and then the other one is minus 2, because the second component is not going to change. And then we got all the features of our ellipse, and therefore we even have drawn the sketch there. Okay, so make sure you sort of understand this. Right. We continue. Right, we continue. We continue. All right, so this is everything we had to do for this question D. And then now we're going to move to the next question, say question 6. And then we shall go back to the other questions. Okay, sorry, because the thing is now, I just pressed another button. So, but now then we're going to go on to the other questions. We're going to go on to the other questions. Let's move on. So now, let us look at 6, number 6. We learned that for the parabola, there are 4 formulas we study. Right, so we shall summarize all the formulas for the parabola. What are the formulas for the parabola? Because when studying a parabola, so now there are formulae for parabolae, or if you don't want to say parabolae, you can also say parabolas. Y minus k squared is 4p x minus h. Y minus k squared is minus 4p. So there are 4 formulas for the parabola. Okay, so we divide like this. These ones are for y squared. And then the others for x squared. X minus k squared is 4p x minus h. Right, so we continue. X minus h. Yeah, so it must be y, this one. Right, so this one will have to be a y. Right, so in other words, we're just looking at the 4 formulas for our parabola. So this one is going to be y minus h. And then now there's this one which is x minus k which is minus. So the parabolas, they always have like a plus or a minus, and then there is y minus. Right, so now this would be the x always goes with what? The x always goes with h, and the y always goes with k. It doesn't matter where the formula is. So we just maintain that kind of discipline. So now there are two formulas. Either the formula has a y squared with a minus or a plus, or it has like x squared with a plus or a minus. But each of these equations has its own characteristic features, which means that this one opens right. Need to discuss how we know which one opens right, which one opens left. This one opens left. This one opens up. This one opens down. How do we know these things, and how can you remember when we are supposed to sketch? Because we must be able to look at the equation and tell if it opens right, left, up, or down. Right, so now let us look at these. So whenever y squared is equal to a positive y squared, I'm just saying y squared here just to, because the k can be 0, but it can be y minus 2 all squared. Right, but it is a y squared anyway. So if there is y squared and a linear x, so this one opens right, because x that is positive is on the right. So this one is positive, this one is negative, this one is positive, this one is negative. Okay, if y squared is a positive, then x is this side. So this graph is going to open right, like this. So this one, when y squared is negative, x is negative, it's going to open left for this one. But there's this one. And now if x squared is positive, y is positive. Y is positive, so it's this one. Here, y is negative. Y is negative down, so it opens down. Right. So these are the 4 basic shapes we need to remember. Okay. So now we are back to our question. We need to find an equation for the conic section satisfying the given conditions. What are the conditions? We have a parabola with vertex. What does the vertex give? So the vertex gives hk. H is for x, we already know. And k is for y, we already know. But if the vertex is 0, 0, then it means this. And therefore, it means our h is 0, but also our k is identically 0 there. So we know h and k. We're going to put into the correct equation here. But we're going to choose the equation that is going to work. Right, so according to the description given, because the parabola has vertex that, okay, so a vertex, every parabola has a vertex. So this notion of a vertex is not enough to give us one description of the equation we're going to use here. So now, there is a focus, okay? Let us look at the focus. So this parabola has a focus at -4 and 0. Let us look at the sketch a little bit more in detail. The vertex is 0 and 0. And then there is a focus at x equals -4 and y 0. Right, so we have at x equal to -4 and y 0. So this is the kind of the graph. This is in particular the graph there. Because we know the focus is this, the vertex is this, and then we have our directrix. We have our directrix. So the directrix, if we talk about the directrix of this one, The directrix is going to be at 4 here, giving us exactly, which is the equation x equal to what? X equal to 4. And that is the directrix because it is the same distance away from the what? From the vertex of the of this graph. Okay. Now we look at the fact that this one is our focus. This one is our focus. Okay, so we need to understand what is happening. This one is our focus. So every parabola has one focus. One focus. Okay, but our ellipse has two foci. Two foci. Right. So now let us look. Okay, we need to find the equation. So which formula is going to work? So we need to just choose from this. But this parabola has opened to the left. It has opened to the left. Because it's open to the left, it's only this one that is going to work. Only this one is going to work. So it is y minus k, you square it, minus 4p x minus h. X minus h. Okay. Now, we continue. Okay, now, yeah, good. We are here. So we're going to put y minus 0 because the vertex is 0, 0. And then we have minus 4p, and then this x minus what? X minus 0. X minus 0. So let us reason and think about this. 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 So we just need to get what? Because we need to get the equation. We just need to get the value of p. That is all. We need to get the value of p. That is all. But to get the value of p, there are a couple of things we can do. So because this one is y squared is minus 4px. But we already know this p is the distance. This p is the distance, always. Given this graph, p is the distance from the vertex to the focus, but also the distance from the vertex to the what? To the directrix. Right, so now that distance is clearly 4, which means that p is what? P is already 4. Which means that y squared is minus 4, the p is 4, and then we multiply by the x, which means it is minus 16x. What is the equation of our parabola? The equation of the parabola is y squared is minus 16x. Minus 16x, and this is the answer. Where's the question now? Who has a question? Who has a question? Right. 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 We'll continue. Right. Right. So this is the answer. Any question about this one? So, but we must know the formulas we need to use so that we can be able to know which formula is going to be used. But how can you remember these 4 formulas?
Sorry.
Yes, please.
Yes, may I ask, how do you know which one to use?
Yes, that's a
Which
question.
one?
So you need to look at so now, like in this question, because there are 4 formulas for the parabola and there are 2 formulas for the ellipse. So now in these charts, in Part 10, we have been looking at the ellipses and also the parabolae as well. So now you need to, in this case, the giveaway was, because I just did the question, I had not done this question ever before, but I just looked at the fact that the vertex is given, and then the focus is given. And then the graph will always open on the side of the focus. So if the focus is this, the graph will have to do this, because you have to cover the focus, meaning this graph is going to open left. If it opens left, then this is the one you need to use.
Okay. Sorry, may I ask, can I have a question?
Yes, please.
Yes, so you said the P is the distance from every time P is going to be the distance from the
Vertex
vertex
to the
to
focus, yes.
the focus. Okay,
And
thank you.
and also the distance, same distance is always, the distance is always the same from the vertex to the directrix as well. So it's always 4, 4, always the same. Okay, right. Now I want us to look at the next question. I want us to look at B now. Okay, you are spoiled for choice. Another parabola. Another parabola. So now let us remember some things here. Okay, what exactly is everything we need here? What exactly do we need in this case here? So we're going to use, I'm going to write all of them. So we're going to write, if they mention we need to find the equation of a parabola, just write all the formulas. So there's always y minus k. So so that you can remember these things. It's not a question of thinking 4 is a lot to remember. But the first two are y minus k, y minus k. Then the difference is going to be 4p, then x minus h, then you put a negative here. 4p x minus h. Then there are there are two formulas for x. X minus h, which is 4p y minus k, 4p y minus k. Okay, so these are the two formulas. Right, these are all four for the parabola, because we need to find the equation of a parabola. So we need to quickly remember these formulas. But this one, when the y squared x is positive, you draw this one. X is positive here, opens right. X is negative here, opens left. Y is positive here, opens up. Y is negative here, opens down. So this one, because x is positive on the right, so it opens right. Okay, these things I'm not saying them myself. These things are on page 740 of the prescribed textbook. Right, so now this one, because now x is negative, it opens left. Y is positive, opens up. And then here it's negative here. So y is negative here, y is negative down. So opens down. Okay, so these are the keys to this one. Okay, right. So now this parabola has focus 1, 1. Has focus 1, 1. Okay. Okay, we'll continue with our analysis of this. So let's put the focus. The focus is at 1, 1. So we're going to do this. We're going to do this, and then we're going to put our focus. The focus is at 1, 1. So x1 and then y is 1. Then we have 1, 1. The focus is at 1, 1. Okay, parabola with focus 1, 1. And directrix y equal to minus 2. And directrix y equal to what? y equal to -2. So if y is -2, we're gonna, okay, the focus is there, and the y is -2. So y is -2, you have this one here, and now you're gonna draw like this. But now this is -2, but yeah, it is y equals -2. So this is the question, and
Sorry.
so now, yes, please.
Sorry for making you go back. Oh, so at number A,
Yes, at
since
A.
our distance, or don't we consider the sign of the distance
Yeah,
like the negative? It will always be
the
positive.
distance will always be positive. Yeah. Yeah, the P will always be positive. Even if the 60 is negative, but the P is always positive because it's distance. Right. Obviously, so that's something we note there. And so now we want to do this one, but this one is just a translated one. So now we have the focus is at 1, 1. The directrix is at -2. Okay. So now you need to think about this, because the directrix and the focus, the vertex is always between them. The vertex. So the vertex is always in the middle, because P is the distance between the focus and the what? And the directrix. If the directrix is this one and the focus is this one, then the vertex is in between them. So now, because of that, then it means that we're going to have the vertex in the middle. All right. If this is true, what is the distance now? The distance from here to there, we want to find the center. Because if this one is -2, then it means that we're going to draw a line like this. We're going to draw a line like this. And then if we draw the line, we're going to find the distance. X is the same, but y is going to be -1. Y is going to be exactly what? A -1. Right, so now if our x is associated with this, it's a 1, then what will our y be? So it means that our y is going to be what? You take half of this, because half of the distance. So because the focus is there, then the graph is going to be like this. It must cover the focus. It must go in the direction of the focus. It can't go down or to the left or to the right. It must contain the focus. The focus must like be in the cup, if the graph is like a cup. So it must be in the cup. So this is everything we need. It is basically everything we need, and therefore we continue. Okay, I was just analyzing the shape. Let me, because this one is on the number, on the equation, so I don't want it to cover the equation, so I can make it a little bit smaller, like this. Okay. With these mentioned, everything is okay. Yes, please.
I got confused at the part of how did we get 1 mapping -1?
The 1 and
Instead
-1.
of, oh, that's the focus. Oh,
Yeah,
okay,
because
my bad.
the
Yes,
focus is 1, 1. The focus is 1, 1. We have shown it here. The directrix is -2. So we sketch -2. But we need to remember that the focus and the directrix are the same distance from each other. From each other. So now if we want to, the directrix and the focus, same distance. Halfway is the vertex, always. Halfway is the vertex. So now, because we are moving vertically, we are moving what? Vertically. Okay, good. So now, okay, there's more I want to say. There's more I want to say about this. Let us pause to reason first. It is in the middle, but this one, okay, you'll have to find half of the distance. The distance between 1 and -2 is what? That is the question. So the distance, you do 1 plus 2, you get 3. So you need to divide by 2. And if you divide by 2, this one is going to give us the P. This would be the best way to do it, because the P is same distance between the directrix and also there. Because now you go up 1 unit here, but you go down 2 units. Well, of course, it's 2 units because we are going in the opposite. So we don't have negative distance. So now, if the distance is 3, you must divide it by 2. You must divide it by 2. Okay, we must divide it by 2. Right, so we continue. We continue. We continue. Okay, now let us see. I wanted to put the correct coordinates here. The correct coordinates, because now if the distance is 2 units down and then it's 1 unit up, so it is 2 plus 1, 3 of the distance. But to get P is always half. Okay, so now it means what? Right, it means that half, it means you're going to measure 1.5. You're going to measure 1.5. So it means that you will have to measure 1.5 here and 1.5 above. If you have, this is it, you measure 1.5 from here to there, or 1.5 from -2 to that. So this one is going to be 0.5. And this one is going to be 1.5. Because 1.5 plus 0.5 then is 2. Oh, of course it is negative. It is negative. But in terms of the coordinates, then it means that you're going to have what for this? It means that because we measure the coordinates from the horizontal axis downwards, so which means that our y is going to become negative half. And then now our x is always on the focus axis. So, and the x component there is 1. So this would be the very correct way to think about it. Okay, but now then you need to choose the equation that is going to work. So which equation is going to work for the graph that opens upwards? For the graph that opens upwards. The graph that opens upwards is where y is positive. So you must choose the graph that is going to have a positive y. You must choose the graph that is going to have a positive y. So the graph that is going to have a positive y is which one? Right, it is exactly this graph, because there's a positive y. So now it means that you're going to throw everything away, all the other equations away, and focus on x minus h squared for p y minus k. Okay. Okay, what is the vertex now? We already can see the vertex. So the vertex, you already have got it. It is 1 and minus 1/2. But this vertex is the hk. Okay, because the h goes with x and then k goes with y. So you substitute everything here. So it is x minus our h for p, y minus our k. X minus that squared for p, y plus 1/2. Now, what is the distance? What is that distance? Because we got the distance between the focus and the directrix, and that one is gonna, if you take half of it, we get p. So we must just substitute the p here. So which means that if we substitute the p there, it's gonna be x minus 1, we square it. So the p, what is the p? The p is 1.5, or it is 3/2. So you put the 3/2 here, and you have this. So it means that you have x minus 1 squared. Now you multiply 4 times 3/2. 2 divides 4, giving us what? Giving us 2. 2 by 3 is 6. Y plus 1/2. And this is the same answer. That is the same answer. So now you must think about this. You must think about this. Right. So these equations are easy to remember. How do you remember these equations of the parabola? You must just say, okay, either it's positive or negative. That's all. So for y squared, so there are two equations for y squared, which is y minus k, all squared, equals. Then either it's positive x. Positive x is on the right. Negative x opens left. X squared, like x minus h squared, x minus h squared. Opens up. Because now here y is positive. And then there's a negative y. And then that one opens down. Think about this. Think about this. Right. So think about this. Right. Think about this. Think about this. So now, any question about this? Let us move on to the next one. Okay, let's look at the C. C is the ellipse, okay, because obviously, I mean, we're supposed to study the parabola graphs, the ellipses, and also the hyperbolic graphs, hyperbolas. Right, so now, here now we're dealing with the ellipse, but this ellipse is easy. There are two equations of the ellipse, so the ellipse is not a lot. There are only two equations of the ellipse. Right, so the first one, x minus h, you square it. So you write x minus h, you square it. Y minus k, you square it. Then you divide. Then you decide what to do. Like, you can decide to put a squared here and b squared equals 1. And then you put always b is smaller than a. A is the biggest one. Or you can do x minus h. You square this and then you do y minus k. You square this and then you're going to do b squared equals a squared equals 1. And then b less than a. Okay, these are the two equations. What is the difference between these two equations? Again, we are back with the ellipse. What is the difference between these two equations now? Because we must think very, very carefully. We must think very, very carefully. So now the actual difference between the equations is that here the merger axis is always parallel to the x-axis. How do we know? Because a is below x. Okay, the merger axis is parallel to the y-axis here. Okay, like that. All right. So we continue. We continue. We continue. Right, so we continue. We continue. We continue. Right, we continue. Okay, let us analyze this. So this is the ellipse, but it has, let's look at the features. It has vertices at this. What does it mean if the vertex is this? But also the foci is this. So, of course, you need to think about this, and you need to think like very carefully about this. Okay. Whenever we have these, you would have the following. You'd have the following. Okay. Okay, now you look at the foci. This foci is on which axis? This foci, now you look at these and reason the vertices are on which axis. So you have the graph like this. Because you need to find an equation, you need to picture the thing. Right, the vertices are on these. So which means that y is 5 minus 5. So which means that the graph is going to be like this. Pretty much. Okay. It's going to be like this. It's going to be like this. Okay, let us continue with our things. Then the foci will be here. Right, so there's a foci at 0, 3. And there's also another foci at 0, minus 3. Like this. Okay, so think about this and make sure you understand everything. Okay. Make sure you understand everything. All right, make sure you understand everything. Right. We continue. We continue. Okay, let's see what you've got. So what do we want to get here? We need to find an equation. So because this equation is like this, and the vertices are like this, the vertices that to do with the merger axis, they give us the merger axis. Meaning the merger axis here is parallel to what? It's parallel to the y-axis. So which means that the graph is going to be this one. We're going to use this equation. But because you can see everything with the vertices, it's 0, 5, 0, minus 5. So it tells us that this graph here, but also you can see same distance, 5 minus 5, has the center, the origin. Has center the origin. Because we know that the center is HK. So it means that here we're going to put H equal to 0 and K equal to 0, so that it is X squared over B squared is Y squared over A squared. Yeah, plus. Plus in the middle. Plus in the middle. Okay, let us analyze more and get some of the things we need. Like, what more do we need here? You see, we would need the A and the B. What is the A and what is the B here? What is the A and what is the B, and how do we determine that? Okay, because now once we get the A and the B here, then we are done. But you need to remember that to get the A and the B, we read them off from here. But once we know the center, you take the center, like 0, 0 becomes a center. Okay. You take the first component. you take the first component. The first component for x, but we can take, so it is, let us deal with the major axis. So the major axis has to do with the A first. And then now you take the center, which is x, y. So which means that for the major axis, we're going to deal with y. So these are to do with the major axis. All right. You take the center. How do you then get the vertex? So you take the center, you add A to it. But also you take the center, you add A and subtract A from the center. That is going to give you the vertex. This is how we get the vertex. You take the center, you add or subtract A. That is going to give you the vertex. The vertex, when you add, you get a 5. When you subtract, you get a -5. All right. This means that you have that A is 5. And then there's going to be a -5 there when it's going down. But yeah, we take positive. We take this one. Right. So now we deal with the minor axis for the B. Right. For the B also, we deal with the center. But for the minor axis, we start with because the minor axis is parallel to the x-axis here. So which means that we're going to start with the first component. We add B to the minor, to the x-axis, to the x component. We also minus B. Okay. We also minus B. And then if we add the B or we minus B, what do we achieve? We get the ends of the minor axis. But you can see that the ends of the minor axis have not been given. So this is not going to give us the B. Because if they'd given us the ends of the minor axis, we're going to get the B. But now then we must get the B from another equation. We can use C equals A squared minus B squared. Okay. So yeah, we can use this one. Because if you do this one, the C, right? So the C allows us to get what? Like we saw before. Something I want to show for the ellipse. For the ellipse. We take the center, we add or subtract C to the center. And also now, then we can actually be in a position to see how much was added or subtracted to get the focus relative to the center. So we're going to use that. We're going to use that. If the center is 0, 0, how much was added or subtracted to get the focus? It was added, 3 was added, and then 3 was subtracted, which means that C is equal to 3. Because it was 3 units, 3 units from the center to the focus. So C became 3. And then we already know A from the major axis, the vertices are given, so which means that our A is 5. From this equation, we can get our B. We square both sides. Getting 9 is equal to, right, so let's continue. Getting 9 is equal to the following. Okay, we're still here. So if you square both sides, you get 9 is equal to 5 squared is 25 minus B squared. Which means that B squared is 25 minus 9, which is 16. Which means B is equal to 4, but B squared is 16, which is this one. So we're done with this one. We got everything. So because the center is clearly the origin, so which means the answer is going to be exactly, which equation is going to be exactly this one. Right. So now if it is exactly this one, we're going to be in a position to see that the B is on the side of the what? Of the X. So which means that with X squared, the B squared, what is the B squared? B squared is 16. Y squared. The A squared. A squared. The A is 5. With the square, it's going to be 25. And the result is 1. So we use the correct equation. See, it's not that the X and the Y are confused or mixed around. Still, it is X squared over 16, Y squared over 25 equals 1. Good. So this is our story. But let's continue now with our investigations here. Right, let's continue right now with our investigations here. Right, let's continue with our investigations here. Let's continue with our investigations. Let's look at the next question. Let's look at the next question. Okay, this one is it's an ellipse, but now we have been given the foci, two of them. Let us picture a little bit and make sense of what is happening here. So the foci at x equal to -1 and y is 1. So we have a focus here. There's another one down here at -1, 3. The minor axis now is given. The minor axis has length 6. So this graph, because the foci are these ones, it means that it's going to be like this. But we need more information about the fact that the minor axis has length 6. So if the minor axis has length 6, it means that you're going to move 3 units here and 3 units there. 3 units here is going to be -4. 3 units here is going to be a 2. And then you have the answer. Okay. We have the answer. We have the answer. Something like this. The minor axis, yes. Now they wanted to give us the ends of the minor axis, but they did not give us the ends of the minor axis, but they just gave us the length. So if we know, therefore, anyway, these are just foci, remember? So the graph is going to go above them. It's going to go above them. So which means that the graph is going to go like this. Okay, it's going to go like this, and it's going to take part of this. How do I even know this? Well, because we already know the foci. So the foci are always inside the graph, because these are not vertices, they are foci. The vertices above, but the minor axis is of length 6. So if we measure the distance from the center, okay, so yeah, there's more we need to do. Right, because if the foci are there, then the center must be in the middle. So we need to find the midpoint of this line. We need to find the midpoint of this. So the midpoint of this, if you go up 1 unit, all right, yeah, is y. 1 unit up, you find the midpoint. You can even use school. x1, x2 divided by 2. But yeah, this is easy. You don't need a lot of formulas here. Like in school, you can say x1, x2 over 2, and then you can say y1 plus y2 over 2. Then you can get the midpoint of the line segment that joins the foci. So you'd say -1 over 2, 1 plus 3 over 2. -1, 2. All right, so we continue. So which means that the center is going to be at x equal to -1, but y equals what? Y equals 2. Y equals 2. That would give us the center. So indeed, it's going to be -1 there, and then 2. And then 2. Okay, you see, there's a mistake in the way this has been drawn. Right, there's a mistake in the way this has been drawn. Because the x-axis is going to become where? Right, so now the things are other way around. Okay, I was looking at the fact that it did not make sense. Something did not make sense, but these are just the other way around. Yx. Okay, so this one is above. This one is below. Yeah, so let's do this. Right, let's do this. So the x-axis is going to be down here. And then you have this point. Like this, because 3 is above, is bigger than 1. So yeah, it's fine. And then now, what is the center? It's -1, 2. And this will give us the center of the what? The center of the ellipse. And then now with this, then we are making progress, and then we just draw the graph like this. Because the foci must be inside it. But these foci are on the major axis, so that it's longer vertically. It's a vertical sort of ellipse. Now, want to get the equation. With the ellipse, there are two equations. Because it's longer vertically, so you write x minus h, y minus k is equal to 1. You decide where to put the a. But because it is longer vertically, it means the a is on y side. And the x is smaller. So this is the equation you want to use. And then obviously when b is smaller than a. Right, so because you need to find the equation, the center is already there. So which means that hk is -1, 2. You find the center, the midpoint of those, which means it is x plus 1 squared, y minus 2 squared is equal to 1. You just need to get the a and the b. But to get the a is going to be hectic. The easiest to get will be the b. Let's see what we've got. Because you just have to do this through the center. And then now if the distance is, the length is 6. The length is 6. And then this is y equals what? Y is equal to 2. Y is equal to 2. Okay, if y is equal to 2, then you measure, this is -1, 2. You measure 6 units. If you measure 6 units, you're going to drift the distance. It must be 3, 3 for it to be 6 total. Right, it must be 3, 3 because the minor axis length. If it's 3, 3, then you have x equal to -1. Then you're going to drift 3 units. The fact that you're drifting 3 units, it gives you b. B is 3. Okay, because now it's the distance. The b is the distance from the center to the end of the minor axis. So the fact that this is 6, you half it, 3, 3. And this means that b is 3. You've already got b. Right. So which means that you're going to have 3 squared. You just need the a now. So the question is, how would you find the A? You think about how you need to find the A, but also think about, it's easy to find the A because you're going to use C is equal to A squared minus B squared, because you have already got B. So which means C is the square root of what? A squared minus 3 squared. Because the B is 3. But the C is the distance from the what? The C becomes the distance from the center to the foci. If the center is this, what is the distance? How much did you go? From 2 to 3, we added what? We added 1. It suggests that C is 1. We added 1. But you also subtract 1. Indeed, C is 1, because now it's 2, you subtract 1. So C is 1. So now you're going to come to this equation and then put C equal to 1. All right. Then you have C is equal to 1. You square both sides, you get 1 is A squared minus 9. A squared equals 10. So A squared is equal to 10. So here you're going to put 10 squared. Okay. So now this is what you have. This is what you have. So now they miss a square there. They miss a square. Oh, anyway, it's fine. They did not miss a square because it is A squared that is 10. So in other words, in the place of A squared, we put 10. A squared is 10. So in the place of A squared, you put 10. So it's okay. And then obviously this one is 3 squared, but 3 squared is what? It's 9. So you can put 9 here like that. So this is the answer. So it means that for this one, we're going to just say x plus 1 squared over 9. Y minus 2 squared over 10 is 1. Okay. So this is the answer, because the 3 squared is the 9 and then the 10 is there. All right. So there are 2 formulas we studied for the ellipse. And there are 2 equations we studied. All right. And so those equations are very important for us to take note of. So that is something very important. This takes us to the end of part 10 about the ellipses and conic sections and the parabola graphs and everything else. When we return, we shall look
Sorry.
at polar. Yes, please.
May I ask, so for the minor axis, since they gave us the length,
Yes.
so basically that's like the total length.
That's
So
the total length. So like B.
So from the center, it's going to be 3 units to the east.
Yes.
Okay.
Yeah, because when they say the minor axis is that, if they said the minor axis length is 6, what would it mean? It means you got 3, 3. You know, so in this case you got 3, 3, but the minute you got 3, 3 for the minor axis, it's going to give us B, because the minor axis gives us B. If it was major axis of length 6, then it means that it was going to affect A. It was going to give us A. And it's going to be 3, 3. Then if you add 3 and subtract 3, then it gives us what? It gives us exactly A. Right. Okay, but this takes us to the end of the conic sections for this part 10. When we return later on today.
Oh, sorry.
Yes,
Aren't we going to revise on the thingy on the polar curves, since I think we didn't finish them?
Yes, that is what we're going to do. Because now we're done with the conic sections. And it's almost 6. Okay, so it means that what we can do, we can take a break. and we'll have to return and look at the polar coordinate questions on Tatan. Okay, because these questions we have done are everything on the conics, 4, 5, and 6. But this is the last question on the conic sections. But I think what you can do is you can take a break. Then when you return, we look at the polar. Okay, let me see. Okay. All right, you're saying, can you please at least do one polar curve before? Okay. Yeah, okay, that's fine. All right, that's okay, because you are interested in us doing the polar curves as well. So we shall do a polar curve question. All right, we shall do a polar curve question. All right, because we did not finish them. Right, so now let's do one polar curve, but it's already, we're going to have a session for them. And I was thinking when we actually return, but because we spend time on the conic sections, it's very important to process this, and then we can look at the other things at the polar, because those are the things that are remaining now. Right. So now let us look at the polar. Right. Let us look at the polar. Let us do one polar, for example. One polar. Okay, so I'm gonna do like maybe 2F, because we have like 15 minutes of time. Okay, now to do the polar question, did you finish this? Okay. That's fine. But now we'll just recap. I know very well that this looks very familiar, but there's something I'm going to mention, because obviously we need to look at where this is 0. Okay, number 1, because this is number 2. Okay, thank you, because obviously, I mean, there are many things I was thinking. We do this, we do that. We do number 1. All right, we do number 1. All right, okay, we shall spend really a lot of time on the polar curves. Shall spend a lot of time on the polar curves because there are many. Let us look at number 1. Maybe, okay, we can do, let me see. Right, sketching G is your main concern. G, okay? Okay, which one is G? Because I'm looking A, B, C, D, E, F. Do you say G? Okay. Which one? Please clarify there. Oh, okay, okay, sorry. Okay, sorry, I thought you were saying G, so I was like, which one is G? Okay, let us start with a dimpled limacon. Let's discuss a dimpled limacon, and then we look at the sketch of these. We look at the sketch of these. Okay, we look at the sketch of these. Now, there are a couple of ways, obviously, in which you can sketch this. And sketch the following polar graphs. In each case, state the values of theta, for which R is the maximum, minimum, 0, etc. Now, if you look at the dimpled limacon, so I want us to look at the sketch of R equals 4 plus 3 cosine theta. Okay, how do we sketch these? How do we sketch this? Okay, to sketch these, we need to use a table. We need to draw a table. So we're going to draw a table like this. And then as part of the table, we put theta R. And then we start with 0. Cosine 0 is 1. 3 by 1 is 3 plus 4, 7. Right, so we need to look at the step of this. Right, so now to look at the associated step of this, because the coefficient of the theta is 1, we're going to actually reason this out and think about what we need to do. Okay, I'm going to give some hints on this one. I'm going to give some hint on this one. For instance, what we're having is r equals 4 plus 3 cosine. Right, so we have exactly this. We have exactly that. So, right, there's something I want to do here. Right, there's something I want to do. So, which means r is equal to 4 plus 3 cosine theta. Right, so now we're going to focus on this and see exactly what we'll do. Okay, there's more I want to say. I want to discuss the step length, or what you call the step size for this. Right, the step size for this. The step size for this. Right, the step size for this. We're going to discuss the step size for this and see how best we can resolve this thing. And see how best we can resolve this one. Right, we're going to be with you now. I would suggest we take it in steps of 30 degrees. Right, so now we can take pi over 6. Then is pi over 6. We're going to do 2 pi over 6, which is pi over 3. 3 pi over 2 pi over 6. 3 pi over 6 is pi over 2. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. 12 pi over 6. Like this. If you put this pi here, cos out of pi it's minus 1. So that you have a 1 there. The 2 pi becomes exactly a 1, giving us 7. Right. Right. Okay. All right. Okay, let us say this. 8 pi over 2, cosine pi over 2 is like 0. Just taking a bit more steps. So you have a 4 there when this is 0. And then pi over 3 is like 60 degrees. Cosine that is 1/2. So it's 3 over 2, and then it is 8 plus 3, 11 over 2, which is 5.5. This one is 4 plus 3, the square root of 3 out of 2. This one is going to be 8 minus 3, which is 2.5. This one, 5 pi over 6, is going to just be negative. Yeah. Yeah, most definitely. It may be a bit hectic. Right. So sometimes you can think of the degrees to be able to get the answer to this. So you'd have, for instance, the 5 pi over 6 is the negative. It's negative because this 5 pi over 6 is in which quadrant? It's here. And we're dealing with cosine. So you think of the cast rule, and then now the cosine is negative here. So the pi over 6, all of them for the cosine is going to be square root of 3 out of 2, negative, positive, but it's going to be negative here because the cosine is negative in this quadrant. So it's going to be 4 minus 3, the square root of 3 out of 2, which is 8 minus 3, the square root of 3 out of 2. Right. So we continue. So now 7 pi over 6 is where? 6 pi over 6 is here. 6 pi over 6 is like pi. So 7 pi over 6 is going to be here. So 7 pi over 6 here in the third quadrant, in which the cosine is what? Is negative. Okay, so cosine negative, so it's going to be the same as this. So it's going to be 4 minus 3, the square root of 3 out of 2. This one is going to just be 4. And this one, 4 pi out of 3. Okay, there's pi over 3, which is 60, 2 pi out of 3, which is 120, 3 pi out of 3, which is pi, 4 pi out of 3 is here, and therefore the cosine is going to be negative there. So it's going to be 4 minus 3 out of 2. What is 4 minus 3 out of 2? 8 minus 3, which is 5 out of 2. 5 pi out of 3. 5 pi over 3 is like close to 6 pi out of 3, 6 pi out of 3, which is 2 pi. But 5 pi over 3 is in the fourth quadrant, where the cosine is positive. Yes. Because, yeah, you're going to be having the 5 pi out of 3 like here, and then 6 pi out of 3, which is 2 pi. Okay, so now if you do the 5 pi out of 3, I know this is a messy thing, but yeah, I'm just trying to brainstorm everything, and then we'll quickly sketch. So the 5 pi out of 3 is going to become what? Right, so the cosine is going to be positive there, which is 4 plus 3 out of 2, which is 8 plus 3, which is 11 out of 2. Okay, which is 5.5. Okay. 11 pi out of 6 is also in the fourth quadrant, in which then it's going to be the square roots. So which means that it's going to be 4, but the cosine is posted there, plus 3, the square root of 3 out of 2. You'll get the answer there. So obviously, sometimes you have no calculator in the exam. So what you can do is you just deal with the estimates. You deal with estimates. So now, let us do something here. 0. When theta is 0, you have 7 units. And 7 looks like the biggest one. And then you have pi over 6. Pi over 6, which is like here. This one is going to be a little bit smaller, giving us pi out of 6. Okay, so it's going to give us your r, which is 4 plus 3, the square root of 3 out of 2, and then the radius is, that is r theta, and theta is pi out of 6. Yeah, let me just check the message. Yes, we can actually use the technique of a plus b or b minus a. Yeah, we'll use the technique of a plus b or b minus a. We'll use exactly that technique. Also, we'll use that technique as well. Right, so that obviously at this point, we shall most definitely use the technique of a minus b in a plus b. In a plus b. Right. So we continue. So we continue. Okay. Yeah, that's fine. And then now at pi over 3, we're going to use the technique of a plus b. And then at pi over 3, the radius is 11 out of 2, which is like 5.5, which is somewhere there. At pi over 2, it's going to be like 4. So r is 4. Pi over 2 is going to be like here. This one is at 7. So in other words, this is going to be the graph. Let us do more. At 2 pi over 3, then you have 2.5. There's 2 pi over 3, like 120 degrees. Then you have like 2.5, which is smaller. So which means that r is this one, and then 2 pi out of 3. And then 5 pi out of 6 is 8 minus that. So which is going to be even smaller. So 5 pi out of 6, r is 4 minus 3, the square root of 3 out of 2 with 5 pi out of 6. So that one is going to be like somewhere there, meaning this is going to be this and it's going to be this. And then now we have pi. At pi, you have exactly a 1. But now the 1 is a negative. So it's going to be like this. Because the cosine function is a symmetric with respect to the x-axis. So whatever you are seeing here is going to be the image of it. We can still take more of these points, but it's symmetry. But obviously, when you return, we shall use the a plus b technique and also the a minus b technique to sketch these, to simplify the sketching so that we don't take forever. But this will be the example of a friend called the dimpled limacon. Dimpled limacon. Dimpled limacon. Dimpled limacon. Right. Okay, now we're going to continue later on because it's after 6 now. We're going to continue later on. When you return, I'm going to send you the time. Yeah, but the best time would have to be, because there's another class for the school kids. You see, every weekend there's a class for the school kids between 8 o'clock and 10 o'clock. So the best time would have to be 11, because after 10, then we might drag a little bit with the kids. So I'm gonna send this recording now. Right, I'm thank you for joining us now. We're gonna return, but we shall look at more techniques on polar caves, because we shall look at like more polar caves when you return. All right. So yeah, the best time to return is 11, because of the class from 8 until 10 of this high school. So which means that we can return at 11 and then explore more of these. But yeah, it's going to be a dedicated session to the polar caves and sketching techniques, because yeah, they can be a bit tricky. Right, thank you for joining us. Until 11 p.m. we shall send this recording just now. Thanks again. Take care. Goodbye. See you at 11. Right, see you at 11.